Today in geometry, we're going to dive deeper into line segments. Those are things that are just part of a line where we know they start, we know they stop, and they're just like part of that line. We're going to focus on how do we measure that, or how do we use some information about them to find out other information about them and their lengths. So we're going to learn about a thing called the ruler postulate, which is basically about can you measure something? Do you know how to use a ruler, or can you count something out to find the distance between 2 points? We're also going to use something called the segment addition postulate, and we'll get to that later in the chapter when we talk about what it is and how to use it. So first thing, we've got to go over some vocabulary. The first thing is a postulate or axiom. A lot of times we're going to have these rules that I give you in geometry class that are called postulates. For example, down here, the ruler postulate. That is just something we call it. It's a rule in geometry that you can just accept it and use it. I'm just telling you something. You don't need to prove it or anything. It's just a rule that you can use to help you do these problems. The next word is coordinate. Now, we all know of a coordinate grid. That's like our x and y's when we graph. X is our left and right, y's is our up and down. So that's just a system where a number represents a certain point in that graph or on that grid. And the most important thing we're talking about today are congruent segments. Now, we say segments are congruent if they have the exact same length. So they're the same size. It doesn't necessarily mean they're the exact same, because we could have one segment going up and down, the other segment going left and right. As long as they're the same length, we say they're congruent because they are the same length, they're the same distance. So let's talk about, how do we find that distance? That comes from the ruler postulate that says, the distance between points A and B, which we will always write as AB with no line, no anything over top. Anytime we're talking about the distance between 2 points, you just write those 2 points. What's the distance between A and B? Well, it's called AB. And that can be found by taking the absolute value of the difference of those coordinates. And really, that's just a fancy way of saying, hey, if just take a ruler and count it out, how many spaces is it from A to B? So let's practice this. For number 1, part A and B, we're going to use this number line that we've got happening over here. Excuse me. So use this. It says, look at segment AB and segment BC. So let's figure those out. Line segment AB, that is from A to B, it's right here. And line segment BC, that's the one that starts at B and it goes to C. So it's right there. Okay. It asks, are those congruent, and to explain it. So if they're congruent, that means that they have the same length. So let's find the length of each of these. For AB, we've got numbers down here, but we can just count it out, right? We've got 1, 2, 3 units. So AB is 3 units. Let's find BC. BC is 1, 2, 3 units as well. So BC is also 3 units. So because these are both 3 units, we say, heck yeah, those are congruent. They're the same length. So are they congruent? We say yes, because AB and BC are length 3. Now notice when I wrote that out, I did not put a bar over these, because AB and BC, we're talking about the distance of them, which is 3. So yes, they are congruent because they're the same length. Let's check out part B. We got 2 different line segments to look at here. We're looking at line segment AC. So let me draw that in my picture. From A to C is right there. And we also have line segment from C to E. That would be this one. So are those congruent? Well, let's figure out what's their length. So what's the length of AC? 1, 2, 3, 4, 5, 6. So the length here is 6 units. And what's the length of CE? That's 4, right? 1, 2, 3, 4. This one is 4 units. So looking at those, are those congruent? No. 6 and 4 are not the same length. So we would say, are they congruent? No. Why not? Well, they are different lengths. Done. Let's check out what number 2 is all about. Number 2 is very similar. It's just, hey, let's practice our graphing skills using a coordinate grid as well. So it says, use the grids provided. First one, we've got plot the points, J, K, L, and M. All right, let's do that first. So point J, remember these points go X first, which is your left and right, Y second, which is our up and down. So J is at -3, 2, 3, 4. 1, 2, 3, 4. So here's point J. K is at 2, 4. 1, 2, 1, 2, 3, 4. Here is K. L is at 1, 3. So 1, 2, 3. And M is at 1, -2. So there's all those points. And then it says, well, draw JK. So I want to connect J and K. Here's that. And LM. So now I'm also going to connect L and M. There's those lines. Okay. Boom. Part A done. Graphing finished. Part B says, now let's determine, are those two line segments congruent? Well, let's find their length. J, we can count it out. 1, 2, 3, 4, 5. JK is 5 units long. So let's see, is LM also 5? It is 1, 2, 3, 4, 5. That one's also 5 units long. So are they congruent? Heck yeah, they are. They're the same length. We would say, yep. They are congruent. They're the same length. Let's try again with these ones. Okay, first we got points A, B, C, and D. Let's plot them. So A, -2, 4. 2, 1, 2, 3, 4. Here's point A. B is 3, 4. 1, 2, 3. 1, 2, 3, 4. C is 0, 2. So x0, y2. And D is 0, -2. So there's all our points. And let's see, which things do I connect together? It says draw AB. So there's that line segment. And CD. There's that line segment. All right. Part B says, are these congruent? What do you think? Are these congruent? Well, let's count them out. AB, 1, 2, 3, 4, 5. And CD, 1, 2, 3, 4. So those are different lengths. That means no, these are not congruent. They're different lengths. So are they congruent? Nope. They're not. Groovy. Let's move on to the next side of the notes. The next topic we're covering today is something called the segment addition postulate. Now this thing just, it's got kind of a fancy title, right? Segment addition postulate, but it's really kind of like like I could have figured that one out. You didn't need to tell me about it. So here's what it says. It says if point B is between point A and C, then the distance from A to B plus the distance from B to C equals the whole thing. Or vice versa, that if AB plus BC equals AC, then B must be somewhere in between A and C. So looking at this diagram here, all that's saying is that if AB, that one part, plus BC, this other part, that if you add those things together, you would get the whole thing, right? One part of a line plus the other part of a line should give you the whole line. That's all this thing is saying. So this is saying that one part plus the other part should equal the whole thing. Which is like, well, duh. If I tell you this part is 1 and this part is 2, well, then the whole thing has got to be 3, right? You just add them together. So let's do this practice. It says use the segment addition postulate to find the indicated length. So we're trying to find DF, which is from here, D to F. So we're trying to find this whole thing. Well, we know that one part is 23, the part from D to E. We know that the other part is 35. So if we add those together, we can find the whole part. 23 plus 35, that's going to give us 58. So that tells me DF, the length of DF equals 58. Let's try part B. It says find GH. So we're trying to find this little thing. And what we know is that one part right here is 21. Plus the other part, that's GH. That's what we're trying to find. We don't know what that is yet. So plus that's what we're trying to find. Well, that should equal the whole thing. That whole thing is 36. Right? If we need to find this part, well, if we know the total thing, we can just subtract away the part that we know. So to solve this equation, well, we would subtract 21 from each side, and that would give us 36 minus 21. That gives us GH equals 15. There's our final answer for GH. Let's try one more. This one's really similar to part B. So we know one part is 37. When we add the other part, KL, we don't know KL. That's what we are trying to find. But when we add those two parts together, it should equal the total thing, which we know is 144. So to solve this sucker, we need to get KL by itself. So let's just subtract that 37 from each side. We'll be left with KL equals 144 minus 37. What's that? That'll give us 107. So that missing chunk is 107. Let's try one more kind of problem, which would be like this. So what if I give you a map like one of these, and I want you to find a certain distance using that map? So with this one, it says, find the distance from Tulsa, here's Tulsa, Oklahoma, to St. Louis, Missouri. Well, look at the information we already have. We know part of the line is 377. If we add the other part of the line, well, that's the part we don't know. That's the part from Tulsa to St. Louis. That's what we're trying to find. Let's just call that X for now. But those two parts together should equal the total thing, which we know is 738 miles. So to solve this sucker, all we got to do is subtract that 377 from each side. And let's see, that tells me that the distance we're looking for is going to be, I can't do that one in my head, 738. Let's turn the calculator on, that helps. All right, 738 minus 377, we get 361. So that tells me it is 361 miles from Tulsa to St. Louis. Let's try this one. It says, find the distance from Albuquerque, New Mexico. It's where my best friend lives, actually. Cool. to Provo, Utah. So we're trying to find the distance from there to there. Well, let's see what we know. We know one part is 231 miles from Albuquerque to Carlsbad. If we add the other part, that's the part that we don't know. That's the part we're trying to find from Albuquerque to Provo. So let's call that X. Those two parts together should equal the total amount, which we know is 680 miles. So to solve it, same thing we did before. Let's get X by itself, subtract 231 from each side. And we get X equals 449. Now just remember, when you're working with these real world problems, you keep the correct units with it. So we're talking about miles. So this 449, it's just not like, 449, that's the distance. We're talking about 449 miles. So let's make sure we have that in our answer. So that's the end of lesson 1.2, where we learned how to use the segment addition postulate here. And where we started was about just finding the length of segments and then seeing if they are congruent, because congruent things have the same length.